Welcome back, Leo Lions. This is Mrs. Morgan with today's lesson over factoring trinomials, but this time we have a different form. We are actually going to have an a value other than 1. So our new form we have here is ax squared plus bx and then plus c. So all of our trinomials will be in this form, and we're going to factor it very similar to how we did with our x squared plus bx plus c. So our first 4 examples here are review. Pause the video and see if you can factor those 4 and get them correct. Remember that what we're doing is looking at our c value, what multiplies to our c value, but then adds to our b value, the middle term. So we would look at factors of 45, what multiplies to 45, and remember it does help to make that list and list them all out. And then you can see 5 and 9 add to 14. So everything in this trinomial is addition or plus. They're all positives. So we knew that both binomials had to be plus. So one is x plus 5, one is x plus 9. And you can always check your work to make sure it goes back. Remember, those binomials can be in any order. Now, it gets a little trickier when there are negatives or minus signs. So what multiplies to negative 28? Right away, I know that my binomials have to be opposite signs. One's a plus, one's a minus. That's the only way we're going to get a negative for our c value. And then what adds to negative 3? So since the middle term is negative, we know that the bigger factor has to go with the minus. So we could look at, again, our factors 1 and negative 28, 2 and negative 14, 3, 4 and negative 7, and there we go. Those two add to negative 3 and multiply to negative 28. So n plus 4, and then the 7 has to go with the minus, n minus 7. Now, the next 2 examples, we have a GCF. So look at our coefficients, 2, 2, and negative 24. So they all have a GCF of 2. Now, only the first and second term have the a's, so we cannot pull out a variable with this. Then don't forget, we divide all 3 of those terms by 2. So 2a squared divided by 2 is just a squared. 2a divided by 2 is 1a, or just the a. And then negative 24 divided by 2. So now we are looking at this a squared plus a minus 12. So my c value is negative, so I know that one of these terms, one of the binomials has to be a plus, the other binomial has to be a minus. The middle term this time is positive 1, so the bigger factor we know has to be positive this time. So we'd look at our factors of negative 12, so negative 1 and 12, negative 2 and 6, negative 3 and 4, and there we go. Those add to positive 1, multiply to negative 12. So the 3 has to go with the minus, the 4 with the positive, and do not forget to bring down that GCF. And if you take your time to double check, you should know if you have these correct or not, because they multiply back to the original. So 4, negative 24, positive 20, so the GCF is 4. We cannot say the P is a GCF because the 20 is a constant and doesn't have that variable. So now divide everything by 4, so minus 6P, and then 20 divided by 4, so plus 5. And now we are factoring this p squared minus 6p plus 5. Now, this example, we do have a positive for our c value, positive 5, but the middle term, the b value, is negative. So we actually know that both these binomials have to be minus. That's the only way we're going to get a positive for the c value and a negative in the middle. Again, I'm going to bring down that GCF so I don't forget. So now both of these are negative. So negative 1 and negative 5 is our only option because 5 is prime. Those do add to negative 6. So one of them is negative 1, the other one's negative 5. Doesn't matter which one's which, the binomials can come in any order. So that is just a refresher on factoring that we have already done. I'm going to show you a couple methods of how to factor trinomials where we have an a value. So the first method is what we call a slip and slide method. So when a cannot be factored out by a GCF, so you always check for a GCF first, then we can possibly still factor the trinomial, not always. Here are the steps in what we call the slip and slide. So step 1, we want to slip the a value. So whatever that a value is to the end of the trinomial and multiply it by the c value. So for example, in 1, our a value is 2. So we're going to slip that a value to the c term, 3, and we're going to multiply them. So 2 times 3, we get 6. And what we're going to do then is rewrite this as x squared, because we slipped that 2 down. The 5x, the middle term, stays the same. And then that 3 now has become a 6 because we multiplied the a term by the c term. Okay? Step 2, now it says factor this new basic trinomial. So we know how to factor terms that have just a x squared, a squared, where the a value is 1. So just like we have learned, we would factor this. Everything is positive, so we know it's going to be both pluses in the binomial. We're looking at factors of 6, so what multiplies to positive 6, but then it adds to that middle term positive 5. So 1 and 6. Ooh, that is not true. 2 and 3, there we go, those add to 5. So one of the terms is 2 and one of them is 3. Now, step 3. We're going to divide both of your factors by the value you slipped over in step 1. So I'm actually, because I have several colors going on here, I want to show you this in a different color. So that a value 2. So in that same color, I'm going to divide by that a value 2 that we slipped. So we're going to divide this factor by 2, and we're going to divide 3 by 2. So both binomials are going to be divided by the a term. All right, next step 4, reduce the fractions and slide any denominators up next to the variable. Distribute and check. So now we want to simplify. If it simplifies to a whole number, like 2 over 2, well, that's going to then simplify to just 1. 3 over 2, that is simplified. Keep it improper. Since that is simplified, we can't divide both 3 and 2 by a number besides 1. Then this is where the slip part comes in. Or the slide, sorry, we slipped the a down to the c. The slide part is to take that denominator and slide it in front of that binomial. So this would become 2x plus 3. Now the first binomial, you could slide that 1 in front of there, but it'd be 1x, that'd just be x. So this is actually x plus, and we simplified it to just 1. So x plus 1, and then 2x plus 3. Now, do not forget, it is very important with these a values that we check our work in the end and make sure that it goes back to what we started with. So x times 2x, we get 2x squared. X times 3, we get 3x. Then the middle terms, so 1 times 2x, and then 1 times 3. And these add to 5x, so 2x squared plus 5x plus 3, that is what we started with. So I know that I factored that correctly. So x plus 1 and 2x plus 3. Again, those binomials can come in any order. Actually, most often we see the one with the coefficient, if there is one, like that 2x plus 3. Usually we see that first, doesn't have to. All right, next one. We're going to do the same exact method. So the a value is 5. We're going to slide that, or slip that down to the c value. So the 5 we take down here, and we're going to multiply. So 5 times 6. So what's left is m squared minus 17m, and then the 6 is going to turn into 30 since we slipped that 5 down and multiplied. All right, now step 2, factor this new basic trinomial. So we know there's 2 binomials. We know that the last term here, the c value, is positive 30. So we know they either have to be both pluses or both minuses. But the inside here, we have a negative 17, so that's where we know, all right, they both have to be minuses. So what multiplies to 30, but then adds to negative 17? So 1 and 30, and they're both negatives, we know. So we're just adding them. 2 and 15, there we go. So one of them is m minus 2, one of them is m minus 15. Now, we are not done. The most common mistake I see is, oh, we factored it, we're good. But remember, we slipped that 5 down, so we still have to continue here. So step 3, divide both your factors by the term that we slipped down. So I'm going to divide this negative 2 by 5 and the negative 15 by 5. Now, negative 2 over 5, we can't do anything there. But 15 over 5, we can simplify that to 3. So we will take this 5, and I want to make sure I'm keeping it consistent to what I did over here. This negative 2 over 5, we will slide that 5 in front of the m. So we end up with 5m minus 2 as one of the binomials. And then this one, it simplified to a whole number. The denominator would be 1. So we don't want to slide the 1 in front of the m. It's just going to stay m minus 3. And then last step, we always want to check to make sure it goes back. So 5m times m, 5m times negative 3, negative 2 times m, and then negative 2 times negative 3 would switch to a positive 3. The middle terms are both negative, so those would combine to negative 17m, which is exactly what we started with. Ooh, we had a positive 6, and when I was checking my work, I did that wrong. Sorry. Negative 2 times negative 3 is positive 6. So there. Now it does match. 5m squared minus 17m plus 6. We are good to go. That is correct factoring. Okay? Pause here, see if you could do the next 2 examples similar to what we have been doing, called our slip and slide method. So first step, and then press play and see if you're on the right track. So we're multiplying our 6 by our 4, so we get y squared minus 5y minus 24. Now we will factor this. Since the c value is negative, we know one has to be y plus and one has to be y minus. The middle term, so what multiplies to negative 24, and then what adds to negative 5. Since the negative is in the middle, we know the bigger factor has to be negative. So 1 and negative 24, 2 and negative 12, 3 and negative 8, and there we go. Those add to negative 5. So the 8 is the minus, the 3 is the plus, and then we want to divide both these terms by the number that we slipped down, so that 6 we're going to divide by. Now simplify the fractions, so 3/6 is going to be 1/2, and 8 over 6, we can divide both those by 2, seeing if there's anything bigger. And then last step, we will slide our denominators over. So 2y, and then there's just a 1 left on top, so plus 1. And then slide that 3 in front, so 3y minus 4. And again, last step, I would always double check. So we get 6y squared minus 8y plus 3y minus 4. Middle terms combine to negative 5y. So 6y squared minus 5y minus 4, it goes back to what we started with. We're good to go on that one. And one more here. So our a value is 12. We will slip that down to the end. So we get c squared plus 11c, and then 5 times 12. So we get negative 60. Our C term is negative, so I know one has to be C minus, one has to be C plus. What multiplies to negative 60, but then adds to positive 11. Our bigger term has to be positive. So negative 1 and 60, negative 2 and 30, negative 3 and 20. negative 4 and 15. There we go. So the 4 is the negative, the 15 is the positive, and those multiply to negative 60. They add to positive 11. Now, don't forget, we need to then divide both these terms by the a value. And now we want to simplify. So 15 and 12 can be divided by 3. 4 and 12 can be divided by 4. And then slide your denominators. So 4c plus 5 is one binomial. 3 slide in front, so 3c minus 1 is the other. And I never really know if I'm correct until I check in the end. 12c squared minus 4c plus 15c minus 5. Combine these to 11c. So 12c squared plus 11c minus 5, it goes back to the original. We're good to go. So that method is what we call the slip and slide method. I want to show you another method because sometimes I find that certain methods work with some people and sometimes they don't. So this is called the AC method, but we're going to learn it by grouping. So our goal is very similar, where we're going to take that A term, so the A term is 3, and we're going to multiply it by our C value. So 3 times 10, we're looking at 30. Now, our goal is to figure out what multiplies to 30, but then adds to negative 11x. We are going to take this B value, this negative 11x, and we're going to separate it into two different terms that will multiply to positive 30, add to negative 11. Everything else stays. That 3x squared stays how it is. And then the positive 10 at the end, that also stays. So we're just separating this negative 11x into two separate terms. So we're trying to figure out what multiplies to 30, adds to negative 11. So we'd have 1 and 30, 2 and 15, 3 and 10, 5 and 6, and there we go. If both of those are negative, those add to negative 11, and then they also multiply to positive 30. So the middle two terms, we're going to separate into minus 5x, and then also minus 6x. So now those two, this minus 5x and this minus 6x, well, they combine to that negative 11x. So we just split them into two, but they also multiply to our AC term. Now, from here, what we want to do is actually group these into two separate parts. The first two terms go together, and then the second terms to go together. This is not our final answer, though. What we need to do is pull out the GCF from each of these two groups. So we're just looking at 3x squared minus 5x. We're looking at the GCF. Well, 3 and negative 5, they don't have a GCF outside of 1. But x squared and x, they do have a common GCF of x. Then we're going to divide both those terms to see what's left. So 3x squared divided by x, we're left with 3x. Negative 5x divided by x, well, the x goes away, so we're just left with minus 5. Do the same thing then over here. So we're looking at GCFs of negative 6 and 10. So a GCF would be negative 2. And then again, we're going to divide both of these by negative 2. So negative 6x divided by negative 2, we get 3x. 10 divided by negative 2, we get minus 5. Now, I want you guys to see what just happened. What's in green here, after we pulled the GCF from each of those, are what we call the twins. The twins, that is one of the two binomials. So one of the binomials is 3x minus 5. The other binomial is created from the GCFs. So x, and since we pulled out a negative 2, if you ever have a negative in there, you want to pull it out. So the x minus 2 is the other binomial. Now, as always then, you would want to double check, does this go back to what we started with? So x times 3x, 3x squared. X times negative 5, so minus 5x. Negative 2, times 3x, negative 6x. And then negative 2 times negative 5, so it goes to positive 10. So 3x squared, and then these combine to negative 11x plus 10. It goes back to what we started with, so we know we are correct. Okay, let's do it again because sometimes it's hard to remember all those steps at once. So your A value, you're going to take and multiply by your C value. So 8 times 3, we're working with now 24. We're going to divide this, or separate this negative 10y into 2 terms. So they must multiply to positive 24, and then they must add to negative 10. Remember the first term, so 8y squared. The last term, positive 3. Those stay exactly how they are. So now we're looking at factors of 24, and they must add to negative 10. So 1 and 24, 2 and 12, 3 and 8. Nope. 4 and 6. There we go. 4 and 6. If they're both negative, they add to negative 10, and they multiply to positive 24. So we're going to separate that into negative 4y, and then also negative 6y. And those are the two that separate, or that combine to our negative 10y. So next step, we're looking for GCFs of each. So group the first 2 terms together, group the last 2 terms together. So GCF of 8 and negative 4, we get 4. The y squared, the y, so they do have a y in common. And then let's pull out 4y from each of those 2 terms. So 8y squared divided by 4y. 8 divided by 4 is 2. Y squared divided by y, so we just get 1y left over. Negative 4y divided by negative 4y, well, it's the same thing, so it's going to simplify to 1. Next step then, GCF of the second, so negative 6 and 3. So this is where if the first coefficient is negative, we're going to be pulling out a negative. Between 6 and 3, they have a GCF of 3, and they don't both have the y, so we can only pull out negative 3. Negative 6y divided by negative 3, so we get 2y. And then positive 3 divided by negative 3, we get a minus 1. Again, look, there are the twins. If you do not end up getting the exact same, then either A, the trinomial cannot be factored, or we made a mistake before and we'd want to go back and check our work. So one of our binomials is 2y minus 1. The other binomial are the GCFs put together. And actually, I'm going to keep this consistent with the last problem. Since I put the twins second. And then the GCFs are 4y and minus 3. So now we can check our work real quick. We would do 4y times 2y, 8y squared. 4y times negative 1, minus 4y. Negative 3 times 2y, so negative 6y. And then negative 3 times negative 1, switch to a positive 3. Middle terms combine to negative 10y. Let's see if that goes back to our beginning. 8y squared minus 10y plus 3. We are good to go. We know we're correct. Okay? Again, you could pause the video here and see if you can do some of these using this method, and then you can kind of decide which method do you prefer. It's totally up to you. So we're going to multiply the 9 times the negative 2. We get negative 18 as our A times C value. We are going to separate positive 3m into 2 separate terms. The 9m squared stays where it's at, and the minus 2 stays where it's at. So what multiplies to negative 18 adds to positive 3. So we have 1, negative 1, and 18. We have 2, negative 2, and 9. Negative 3 and 6. There we go. They add to positive 3. So one of them is going to be minus 3m. The other one's going to be positive 6m. Those combine to positive 3m and multiply to negative 18. Now, you can write either one of those first. It really doesn't matter. You're going to get the same answer in the end. So group the first 2 together. GCF of 9 and 3 is 3. M squared and m, so GCF is 3m. Divide what's left, so we get 3m, and we get minus 1. GCF of 6m 6 and negative 2. So we're going to pull out 2. They do not have a variable in common. And then we get 6m divided by 2 is 3m. Negative 2 divided by 2, negative m, or negative 1. And now I can see those twins. So 3m minus 1 is one of the binomials. The other one, and that 2 is positive this time, so it's actually going to be 3m plus 2. And then last step, check your work. 9m squared minus 3m plus 6m minus 2. And the negative 3m, 6m combine to positive 3m. So we know we're right. And for sake of time, I'm just going to show you one more using this method. So our 10 times our c value. So we get negative 20. We're going to separate negative p. So we want it to get to negative 1. And we're going to separate that into two terms. 10p squared and negative 2 stay where they're at. So what multiplies to negative 20? The bigger factor has to be negative since the middle term's negative. So 2 and negative 10. 3 doesn't work. 4 and negative 5. There we go. So I'm going to do plus 4p minus 5p. And that's where those two terms combine to our negative 1. Now let's find our GCF. Group the first two terms. Group the second two terms. 10 and 4, GCF is 2. P squared and p, so we can pull out a p. Then divide what's left, so we get 5p plus 2. And now we have negative 5 and negative 2, so there's no GCF between those, but there is a negative in common. So we want to actually pull out a negative 1, and you're going to see you always want those twins, what's left in the parentheses, to be the same. So that way, negative 5p divided by negative 1, we're going to get positive 5p and positive 2. Now we see the twin binomials there. So one binomial is 5p plus 2. The other one is our GCFs, 2p minus 1. And if you use this method, we're actually going to be eventually factoring 4 terms, and we're going to factor by grouping like this. So this kind of gives you a step ahead of what we're going to do in the future if you end up using this method. So I'm just checking my work here as I'm talking and trying to make sure I'm not making any mistakes. Positive 4 minus 5, so we do get negative 1. 10p squared and minus 2, they're the same, so we know we're right. So there we go, there is factoring with an a term. There are a couple more examples down here at the bottom because every single time our first step has to be factor out a GCF. So sometimes we can actually pull out a GCF before we even begin our factoring. So 10, 75, 35, our GCF is 5. They do not all have a k in common because 35 doesn't have it. So now we divide everything. 10k squared divided by 5, we get 2k squared. 75k divided by 5, we get 15k. And then 35 divided by 5, we get 7. So now we have a GCF out front, but we have a trinomial that has a value of 2. So again, several different ways, whichever method you prefer. I'll do one of each. So 2 times 7, that means we're working with our AC value of 14. So I'm always going to bring down that GCF so I do not forget about it. The 2k squared stays, the 7 stays. We're going to separate 15k into 2 separate terms. So 1 and 14 multiplies to our AC, and then it also adds to 15. So I'm going to do one as 1k, the other one as 14k. And everything is positive here. So let's group together our first two and our last two, pull out a GCF. 2k squared and 1k, we just have k. And then we have 2k plus 1 left in the parentheses. Now, I am not going to forget and make that mistake of bringing down my GCF, so I'm also going to bring that down. Then GCF of 14K and 7, so 7 is our GCF. Divide what's left there, we get 2K plus 1, and there are our twins. So when we rewrite this, we have to have our GCF, then we have our GCFs of the trinomial. So we have K and positive 7, so K plus 7. And then we have our twin binomials, so that's our last binomial. And then don't forget, check your work. We could multiply the binomials first. So 2K squared plus K plus 14K plus 7. Those add to 15K, so that works. But we still have that GCF on the outside. So we'd have 10K squared. That's now 15K in the middle. So times 5, we'd get 75K. Oops, and I forgot my squared. And then 5 times 7, so look at that. It goes back to the beginning. So here is our factored polynomial. And one more I'm going to do with you. So a term is our 12. So this is, I'm going to do our slip and slide. Whoops, I forgot something though. We need to pull out the GCF. So this example, we have 12x squared, we have 2x, and we have minus 2. So we're actually going to pull out a GCF of 2. And then divide everything that is left. So 6x squared plus x minus 1. Now we're going to do that slip and slide method. So positive 6, we're going to slip down here. And we're going to rewrite this as x squared plus x minus 6. And I'm going to make sure I bring down that GCF. So now we are going to factor this. The C term is a negative 6. So I know that one of these has to be x plus, one has to be x minus. And we're looking at terms of negative 6, or factors of negative 6 that add to positive 1. So we have negative 1 and 6, and we have negative 2 and 3, and there we go. So x minus 2, x plus 3, and I'm bringing down that first GCF. And now whatever we slipped down to the end there, that 6, we're going to divide both those by 6. So I'm just doing the other method that we learned on the front side. And then we will simplify. So this would be 1/2. This would be 1/3. We want to take our denominator and slide it to the front. So 2x plus 1. And then we get 3x minus 1. And don't forget that first GCF. And there we are done, but I am going to double check. Multiply binomials first. 6x squared minus 2x plus 3x minus 1. Middle terms combine to positive 1x. And then let's distribute our GCF and see if it goes to the original, 12x squared. Remember that middle combined to 1x, so 2 times 1x. And then 2 times negative 1. And let's see if that's what we started with. 12x squared plus 2x minus 2. Perfect. So we know we are correct. Okay? There are some extra 4 questions there that we have not completed, so you are welcome to complete those on your own. And if you're checking your work, then you know if you have factored them correctly or not. So there is factoring with an A term, a longer video because I showed you a couple different methods, and I also showed you those examples with the GCF. So the more you do them and the better you get at remembering those rules, the better you'll get at solving.